For our first example here, we're going to go ahead and look at the data set on the left. I've got x values and y values, and I'm going to go ahead and calculate the correlation coefficient for them. To begin, I need to find my averages, and if I average those x values there, I get an average of 4. And if I average the y values, I get an average of 2. Having those, the next thing I need to do is calculate my standard deviation, and when I calculate that standard deviation, I get 2.92 and 1.22 there. Final thing I need is n, and when I find n, I go ahead and I look, and I've got 5 points, so n will be 5. Using all this information, I'm going to go ahead and fill in my columns in step 2. First column is my x value, so I'll write them down, 0, 2, 5, 6, and 7. The next thing I do is I find the deviations, that is how far off they are. I'll do that by taking x minus x bar. So 0 minus 4 to begin with, which will give me negative 4. 2 minus 4 will give me negative 2. 5 minus 4 is 1. 6 minus 4 is 2. 7 minus 4 is 3. Now, a good way to check to make sure you've done this correctly, your deviations should add to 0, unless there's been a little bit of rounding in it. So these add to 0, I'm good. I'll go ahead and list my y values next. My y values go 1, 1, 2, 2, and 4. I'm making sure to keep those rows straight. Then I'll find the deviations by taking y minus y bar. So 1 minus 2 is negative 1, 0, 0, and 2. Once again, those deviations add up to 0. Final column is to go ahead and multiply my deviations. So I'll take x minus x bar times y minus y bar. When I do that, I'll get 4, 2, 0, 0, and I believe the last one will give me 6. Having done this, the next step, step 3, is to go ahead and add all of those together. So when I add my deviations, I can use that sigma to represent the addition. And adding them together, it looks like I get 12. Next step after that is I'll divide that by my n minus 1 times sx times sy, which means when I do this here, I'll go ahead and I'll take my 12 and I'll divide it by n minus 1 is 4 times my standard deviation for x, which is 2.92, times my standard deviation of y, which is 1.22. And what this will give me then is my r value, my correlation coefficient. And something to notice about this example is I got a really high correlation coefficient. I got 0.84. This means that when I graph my data, it'll have a positive association, and it will be roughly linear. Pretty much in a straight line, but not exactly straight, because that would mandate I have r equals 1.